8, go.
Welcome everyone to the Robofest game Stack Rolls workshop for Scratch with Robot Inventor and Spike Prime. My name is Elmer Santos. I am the Robofest Assistant Director. This file, along with others, can be found in the eAcademy section of the robofest.net website, along with other online training and certifications. This workshop is presented by Lawrence Technological University Computer Science Department. Okay, here's the overview for today. We are going to review the game challenge, introduce the workshop robot, and then demonstrate techniques for using the robot to solve the challenge. Okay, next is the video. So lots of stuff can be found on our Robofest website. So I'm going under the game page, and here's a demonstration. And I'm going to talk through I'm going to turn the sound off and then describe some of the techniques as we go through Now this is not a Spike Prime robot, but it uses similar techniques. Okay, here you go. So it's detecting the edge and then turning, then detecting the roll, following the edge until it detects the target zone, lifting the roll, lowering it onto another roll, grabbing the stack, and now it's going to turn until it detects the edge again, follows the edge, goes across the other side till it detects the other edge, turns, follows the edge, goes to the target zone until it detects the target zone, and it grabs the roll, turns, releases it, it backs up, detects the edge, follows the edge till the right sensor detects the far edge of the table, detects the edge, follows the edge until it detects the target zone, and then releases. So you probably noticed that there's a lot of detecting edges, following edges. So that's going to be a big part of the workshop. So these are the tasks we're going to cover: finding the edge of the table, following the edge of the table, being able to stop the robot when you reach a corner or the target zone, being able to stop when you reach a given distance, some ways of turning the robot, aligning the robot to the edge, being able to manipulate the paper rolls, basically grabbing them and picking them up and then lowering them and releasing them. Building what we call my blocks, which is a way of its custom code that you can reuse. And then something special with the Spike Prime robot, we're going to cover gyro turns, being able to use the built-in gyro sensor to get accurate turns. So that's the agenda. I'm going to try to get through all of these. If we run out of time, it's all in the presentation, so you can go over that on your own. But I'll try to get focus on the most important task. All right, so this is the configuration we're using. Hopefully you have something similar. That's Spike Prime robot with the drive motors in A and B. Right, left motor A, right motor B. Arm motor in C, claw motor in F, and then color sensors in D and E. And specifically, again, left motor is in A, right motor is in B, the arm motor is in C, right color sensor is in D, left color sensor is in E, and claw motor is in F. So hopefully everyone's got something like that. We're using the latest, I believe this is the latest version, 1.3.3. This is the website if you need to update. And once again, all this information is under tech resources on our website. Okay, this is the overview of the new Spike Prime, or Robot Inventor has a similar hub. It's got ports which are labeled A through F. These ports can be used for either motors or sensors. There are only 6 of them, which does create some limitations. It's also got a scrolling display. So instead of an LCD like the EV3, it's got a display which only displays one character at a time, but it scrolls so you to be able to read more than one. And then at the bottom, there are keys. There's a center button, which is also the power button, and then there's a right and left key. Okay, so let's get started. Yeah, I'm gonna switch to a live demonstration. Yeah, hopefully you can follow along. Yeah, start up your software basically by double clicking. Also turn on your robot by pressing the center or power button. Okay, when you start software, you'll see something like this. We're going to start with a new project. We're going to use the word blocks. And I guess you can give it a name here or change it later. Yeah, I'm just going to call it workshop February 20. Then hit create. Okay, then you'll be in the programming environment, where the work environment's in the center. Off to the left are your menus, right? If you work with Scratch, it's very similar. Basically, your submenus here, and then all the blocks, specific blocks over here. But first, we need to connect to the brain. So the way you do that is you hit connect, and then you can use either Bluetooth or a cable. I'm going to try Bluetooth on mine. Okay, yeah, so you found it. I think the one I'm using is called Robofest 1. If you have problems with this, you may have to connect through Windows, set up your Bluetooth through Windows before you do this part. But yeah, once you do that, it should be pretty reliable. Okay, next thing I want to go through is the settings. So all your devices you can see are right here, and you can set the mode for them. So the motors we can leave, it's set to display in degrees of rotation. But for the 2 sensors, D and E, we want to make sure they're on reflection mode. Right, you can see on my robot, they're showing 99%, so they're on a pretty bright surface, which basically is the game table. So yeah, so set them to reflect, and then you can click the X and go back to the menu. Then yeah, you'll notice you see the live sensor readings up here. Okay, we're going on to task 0. I should mention that the latest version of this presentation is on our website under tech resources, and I will also email this out after the workshop just to make sure you have the latest version. Okay, so yeah, task 0 is to move the robot until it detects the edge. Yeah, maybe it's better if I display. I'll show you how that looks. Simply, robot moves until the sensor detects the edge, and then it stops. Let's do that one more time. Moves forward until it detects the edge, and then stops. So a number of ways to do this. But yeah, we'll start with the first way. Just if you go into movement, you want to set your drive motors. So the default's A and B. So that's how we've set up the workshop robot. So you just leave it A and B. And then the next thing is you want to get the robot moving. You actually want to, there's a block that I believe you can get it moving and set the speed at the same time. Let's see, move. Yeah, actually, yeah, this is good to know. You should add the more movement option. Yeah, actually, probably the more sensors might be useful too. And you get that by clicking down here. Yeah. Okay, so under more movement, you see there's a combined, you can start it moving and set the power at the same time. If you don't have this or you can't find it, you can always use separate blocks too. But yeah, I'm just going to continue with this for now. Okay, so you can adjust the steering, but we just want it straight. Set the power. I'm just going to leave it at 50%. And then we want to wait until it detects the edge. So it's basically control, wait until, and then sensor. Right here. Okay, D. And then you want to stop it. All right, so yeah, please give that a try. Yeah, and again, D is the right sensor on the workshop robot, so it should wait until the right one detects it. If the left one detects it, nothing's going to happen because it's only programmed for the right one. Of course, you could change it if you want the left, like that. Okay, another way to do this, yeah, I guess I'll show a couple different ways. Yeah, as I mentioned before, you don't have to use this combined block of view. You're just using the standard menu. You can just use a separate, start moving straight, set the power, and then, yeah, this will work. Also, rather than using a wait until, you can use a loop. Repeat until instead of wait until, but it's the same thing. Yeah, all these basically do the same thing, all these combinations. Now the one thing to kind of add to this, oh yeah, there's an undo button that's kind of nice too. We'll stick with the Yeah, I'd mentioned earlier that it's only detecting one sensor. You really want it to stop at either sensor in most cases. So that's fairly easy. You just need to find an OR condition. So you change this to, instead of just that, you do either D is less than 50 or E is less than. So if either of these conditions is true, if either sensor detects the edge, it will stop. Yeah, we'll get into this a little more later, but just to show you how it's pretty easy just to add the sensor with this software. Okay, so that's the first exercise. Okay, next we're going to go on to task 1, which is following the edge of a table. We're going to use what they call zigzag methods to follow the edge. So basically, if we're following the edge of the table, we look at the sensor on the table or off the table. If it's on the table, you want it to go off the table. If it's off the table, you want it to move it towards it goes on the table. So you notice it's never actually going straight. It's just going back and forth. That's why they call it zigzag. Right. So so again, it's really important to know whether the robot is on the table or off the table. So that's where we're going to look at the sensor readings in a little bit more detail. And let me just give a quick demonstration while I'm here of what that looks like once we start moving. Okay, see, it's really zigzagging, right? So that's really the basics. And we call it line following. In the case of the Robofest game, we're actually following the edge rather than the line, but it's the same principle, right? Dark and light, zigzag methods. Okay, so let's, I'm going to save some of these blocks because I want to use them again. You can do that by, if you leave the blocks kind of hanging out in space instead of attached to a when program starts button, they won't execute. Oh yeah, another thing I should mention with the Scratch software, it's probably good to set the motors to to values and then leave them there. And once you do that, you don't have to keep repeating it. But probably one of the first statements when the program starts is to set your drive motors and then just leave them there. Okay, so yeah, a couple things. First, we need to determine thresholds. Okay, as I mentioned, my robot is on the table, so both sensors are on the table. Yeah, if I move it so that the sensors are off the table, you can see that the numbers are quite low now, right? They're both reading 4%. Okay, so I think we're going to be programming the left sensor, which is E. Okay, so if you look, E is 4% off the table. It's like what, 90%, 99% on the table, quite a bit of contrast. So a simple way of doing it is you take the average of the numbers, 99 plus 4, what's that, 103? Yeah, so it's about 50, 51. Yeah, I mean, we can just call it 50, right? That there's quite a bit of contrast. Yes, that's how we got to this number of 50 in the example, which happens to be the default, but it actually works out pretty well. So yeah, I'm just gonna take that one. All right, so now that we have a threshold, we want to set a condition, right? Condition is basically a yes or no question. So I'm going to go and, oh yeah, first we need a loop, a forever loop under control, forever. Okay, and then we need an if, then, else. And then we need our condition. So the condition is the E sensor, it's a left sensor less than 50, right? So basically ask, is the sensor off the table? And if it is, we want to turn one way, and if it is not, we want to turn the other way. All right, so you go to movement. Yeah, actually, let me find my notes here again. Oh yeah, that's right. We want this fancy block that's under more movement, combined block. Okay, so if the left sensor is off the table, we want to move towards the table, which is a right turn. So I'm going to say right, about 20 degrees of steering at 50%. And if it's not off the table, that we're assuming it's on the table, so we want to turn away from the table, which is a left. So you can just duplicate it and then change that to left 20. All right, so give that a try. And it should be similar to the video where it just zigzags. And that's your basic edge following. And I'll pull up the video one more time. And it should zigzag like this. See, it's, and there are lots of different things you can do once you get this started, but this is the basic algorithm, right? You can adjust the steering, the power, right? You can get more wiggle, a little less wiggle. That's one thing to note. More wiggle also means it's got more forgiveness, more ability to stay on the edge. If you have less steering, less wiggle, it tends to be straighter, which can be a benefit in situations, but also it's also more sensitive to losing the edge, we call it, basically not being able to stay on the edge. So keep that in mind when you try different numbers. Okay, so that's simple line following. There's also yeah. Okay, so next we're gonna follow the edge or the line, and then we want to stop based on different conditions. So the first condition we're going to look at is just trying to detect the corner, the end of the table or the corner of the table, or in the case of this game, it's helpful if you're able to detect the target zone. So basically, we use one sensor to follow the edge, then we use the other sensor to detect the end of the table or the far edge. Yeah, so you recall we have our basic program, and what we have to do is replace this forever loop with a loop that has a condition for stopping, and then finally to stop the robot. And here's a video that demonstrates that. Okay, it's following the edge, and then you see the other sensor detects the target zone and stops. So it's basically just looking for something dark. Can be the other edge of the end of the table, or it can be the target zone. So that's kind of convenient. All right, so that's what we're trying to do, and this is how you do it. As I said, you have to replace this forever loop. Yeah, and I think yeah, you just pull it over here to throw it away, throw blocks away. Go back to control, and then we want a loop with a condition. Yeah, that would be repeat until. You put that back, and that condition is that the other sensor, the D sensor, is dark. Yeah, so repeat until D sensor is less than 50 where it's dark. And then after that, you have to remember to stop the robot, right? Because afterwards, it leaves a loop, but it's still moving, so you want it to stop. Okay, so yeah, that's basically it. You exchange the repeat forever for repeat until, make the condition until the other sensor, the D sensor, is see something dark, it's less than 50, and then stop. So again, it should look like that. Pretty basic. Couple potential, I guess, issues. So if the robot doesn't stop, what could be the problem, right? Possibly, if it doesn't stop, it means this condition never was true. So the condition is, so it never saw anything less than 50. So perhaps 50 is too low, right? If it never stops. If the robot stops immediately, it means it saw that condition immediately. So perhaps that condition is too high. So if there's a problem, one thing to do is check this condition, right? Check the amount, check the sign, check the sensor, right? And it's most likely one of those things. So that's how you line follow to the corner of a table or to the target zone. Okay, any questions so far? Okay, all right, good. Okay, we're going to continue on. Next task, line following for a given distance. This is very similar to following to something dark, right? The last thing we just did, but it uses the built-in rotation sensor. Okay, before we do that, we're gonna talk a little bit about the rotation sensor and just measuring distances in general. All right, so we're going to talk about computing the distance traveled by measuring the number of rotations of the wheel. Right, this involves the wheel geometry. Right, you may recall the circumference of a wheel is the diameter times pi. In the case of the spike prime, I think it's conveniently similar to the EV3. It's a 5.5 centimeter diameter times pi. So here's the formula. The one thing with the scratch, I believe you have to convert from degrees to rotations. So that's degrees divided by 360. So it's the circumference, 17.28 times the times the number of rotations, which is degrees divided by 360. Oh yeah, one thing to note with the spike prime, the right motor moves in the positive direction and the left motor moves in the negative direction. So yeah, you probably I suggest you use the right motor to minimize mistakes with the sign convention. Okay, so what we have here on the right is a basic program which drives straight for 2 seconds, and then we just measure how far it went. So we set the motors to move straight, reset the rotation sensor for the right side motor, the B motor, to 0. Then we move for 2 seconds at 50%. And then after that, the robot has stopped. So we just simply need to calculate the distance. This is the formula we just went. So we're going to save it in a variable called distance, which is again the distance. And again, the formula is the 17.28 times the relative position of the motor divided by 360. And then we want to display it. So I just set up a little loop where you're displaying the distance, and you do that until the left button is pressed. All right, so let's go through that. Yeah, let me find my place in the presentation here. Okay, yeah, we're going to set the motors A and B. Then you go to motors. Okay, set motor. Okay, maybe. It's the one. No, that's not the one. Okay, I'm not seeing my. Okay, let me check. This might be up. Yeah, I think we need another menu. More motors menu. Let's see if that's in there. Yeah, okay, yeah. Sorry about that. We need the more motors menu. So in there is the set relative position to 0, and it's the B motor. Okay, and then we want to start it moving straight at 50%. Again, then the more movement. Okay, then at that point, we want to measure the distance. All right, so under variables, I'm going to make a variable. I'm going to call it distance. And then we're going to set the distance to a formula. Let's say it was relative position. Yeah, right here. Okay, so this is how far it's moved. And we convert that to, that's the degrees. You want to convert it to rotations, right? So you divide by 360. And then you want to multiply that whole thing by the circumference, right? So we need a multiplication block. And put the circumference. All right, so that should give you your distance traveled. Oh, I'm sorry. I think I used the okay. Sorry. We need a 2-second. Okay, I think that's actually in the standard. Yeah, sorry. You got a lot of similar blocks, so we want to move straight. 2 seconds. Okay, yeah, that's not exactly it, but again, they're multiple ways to get the same thing. Yeah, we want 50% moving straight for 2 seconds. Okay, then we want to display the distance traveled, and that's the formula to convert to distance. And then lastly, we want to display it. So we go to get a loop. We want to display, which is this one. Yeah. All right. Got a variable, distance, and then yeah, you can do it forever if you want, but I just wanted to put a way to stop it from displaying. So I'm just going to use one of the buttons. Yeah, you can whatever button you want. Let's leave it at default. Okay, so I believe that should work. Yeah, give that a try. And again, there are several ways to do the same thing with this software. But the important part to remember is you set your motors, you set your rotation sensors to 0, you move your robot at 50% for 2 seconds, and then you calculate the distance traveled and then display it. So give it a try. And I think we have a video of what it should look like. Yep, it should look like this. This goes straight, and then here's where we use the scrolling display. I think it says 43.2. I believe that's what that's showing. That's how the scrolling display works. 43 point something. Yeah, 43 point. I think it might be a 7, but yeah, it's basically about 43 centimeters, right? It's about how far the robot moved in 2 seconds at 50% power. Okay, so hopefully that is hopefully that worked out for you. And then we're going to go on to the next part, which is combining this with line following. So it's basically similar to our previous task, which followed until it detected something dark, except for the condition is you're looking for the position of the rotation sensor. Using the rotation sensor, you have to reset the sensor first, and then go until it's at a certain position. And again, this position is based on degrees, and you can convert that to distance if you want. Either way works. Right, so here's an example of it. You see it's following. Yeah, this was a short distance, but the thing to note that it basically went a certain distance, right? There was no dark spot or edge of a table to the text. It basically just went until it went to a certain distance. And if you want it to go more distance, you can adjust this number higher, less distance, lower. Right, so that can be very helpful for doing the game, right? If you're trying to push a roll for a certain distance, yeah, this would be the method. All right, so yeah, let's do that. Yeah, I didn't save any of my work, so we're gonna. Okay, well, actually, this might be for the undo. We'll see how far we can undo. Okay, yeah, actually, so if you go back to where we were, we can convert this pretty quickly to the following the edge for a distance. You have to remember, I think we were using those more motors. You want to set the relative position of the B motor, because that's the one that goes in the positive direction, to 0. And then you want to repeat until repeat until the B motor is greater than some amount. Again, more motors, make sure you select the B motor. And then, right, what is this number, right? It's based on the circumference of the wheel. So if you wanted to go 17.28 centimeters, right, which is one rotation, that's basically 360 degrees, right? And you can just do it that way. So however way, right, just remember, yeah, get the signs right. Just understand the units you're using, right, that this is degrees. And you should be able to make it follow the edge for a precise distance. Yeah, so if you want to do like, what, 2 rotations, that's 720? That's approximately 35 centimeters, right? So give that a try. I'll give you a few minutes to try that, and then we'll move on to the next part. Let's see. Oh, yeah. In the meantime, I'm going to reset my robot. It seems to have timed out. Yeah, again, this is the code. Yeah, if you want to blow it up here. Very similar to following the edge to the corner, right? The code's the same inside the loop. It's just the condition of terminating the loop is different, where we're using motor position to determine when to stop. And again, it should look like this. Oops, follows. Yeah. And this is very short distance I use, but you can do longer distances by just increasing the number here. So hopefully you got that to work. And we're going to move on to the next section, which is turning the robot. Yeah, similar to other robots, Spike Prime can be used to do either a swing turn or a spin turn. And we're going to go through the spin turn, which is probably the more common turn, right? The robot basically just spins in place, right around the center of rotation, which should be between your drive wheels. Right? In most cases, we're using a two-wheel drive, so it'll be right here, right, 90 degrees. All right, so it's pretty simple. Just one block. And it should look like this. Yeah, that's a spin turn. Oops. Yep, there's a spin turn, and then go through the code. Actually, let me turn this off. Okay. Yeah. So spin turn code is this one block. Yeah. Yeah. Again, this assumes that you've got the correct default. Yeah. What was that one? We were doing a left turn. So left turn, send it all the way full left, minus 100. And then we're using degree rotations, I think. Yeah, rotations. And 0.55. So that's all it is, very simple. So give that a try. And then we're gonna also show you the swing turn. All right, for the swing turn, what we do is we lock the left motor and then we power the right motor to turn the appropriate amount. Okay, here's the swing turn. Lock the left motor, move the right motor, and then you just got to figure out what the appropriate amount is. Yeah, I think it's one rotation, but let me check here. Okay, so lock left motor, the A motor, run the B motor. I'll give that a try. Oh, yeah, I lost my connection. Yeah, so I'm going to reconnect to the hub. Oh, that's the wrong. Okay, well, looks like I'm having trouble with my connection, but yeah, give it a try. Yeah, I believe it. I believe one rotation is the right amount for the the Spike Prime, but yeah, it might vary slightly. Okay. Okay, what, there's a question? Oh yeah, relative to position to the motor. I mean, it's just basically relative position to 0. So we set the position to 0, and then when you call the relative position block, you're just measuring how far from 0. I believe that's how that works. I'm gonna attempt to restart my software here.
So Elmer,
Yeah.
Yeah. So what's the difference between the relative position to with the shortest position? Because I was using the shortest position.
Did you get similar results?
Yes.
Okay. Yeah, there probably isn't. They're probably the same. I think with relative position, perhaps you don't have to reset it. Yeah, I don't know exactly sure. I might have to look into that some more.
Okay.
Yeah, but yeah, like with the other things, it looks like there are multiple ways to get the same, or similar results. Yeah, so I'll get back to you. I'll have to see what the delve into the details a little bit more.
Yeah, when I use set the shortest position to motor like 0, the motor will go back to its original position, which is the default position. So I'm not quite sure. Yeah.
Okay. Yeah. I think I know you do a little more investigation.
Okay.
Yeah, I believe it. Yeah. Okay. Yeah. I'll let you know. Okay. It looks like I'm back online. Let's move on to the next one, which is aligning the robot to an edge. Which, if you remember the video, that this is important kind of thing. Right? If you can establish that the robot has both sensors on the edge at certain points during the game, that will be very, very helpful. All right, so here's how you do it. We're going to start with a kind of a more specific case and then try to generalize it. Okay, so if we travel till the D sensor, I keep forgetting which one is, that is, sees it first, and then swing the robot till the E sensor is. Okay, A. Okay, the D sensor must be the left side, according to this code. Okay, so again, you set the motors to forward. Yeah, I use a low speed 25, go straight. Okay, this assumes that you're gonna see the edge with the D sensor first, the left sensor, and then stop the left motor, and then continue moving the right motor until the other side sees it, and then you stop. And then at that point, both sensors should be on the edge. Yes, there's what it should look like. D sensor. Okay. Yeah, actually, it looks like it's the right side for this one. Yeah, sorry about that. Let me just verify. Yeah, okay. Yeah, sorry. Yeah, left motor is A, right motor is B in our robot. Left sensor is E. Left sensor is E, right sensor is D. Okay, there might be a mistake here somewhere. D. Yeah, okay, I guess we're gonna have to experiment a little bit. So let's just try that. Yeah, actually, I will check my specific robot just to make sure. Okay, so it looks like on my robot, it's a little hard to read these things. On my robot, the D sensor is on the left, actually. Yes, I think the video is the one that's incorrect. Okay, my robot, the D sensor is on the left. And the left motor is A. So D and A. Okay. All right. So yeah, sometimes it you have to kind of walk through these things. So D and A. Okay, so we want to start the robot moving straight at 25. And we want to wait until the D, which is the left, see something dark. And then we want to stop the right motor, but we want to continue the left motor, which is B, moving at 25%. And we want to do that until the other side, the E, see something dark. And then, yeah, what did we use for the example? Yeah, and then at that point, we want everything to stop. So, okay, let me give that a quick try. Forward. Yeah, let me set these up again. D. Okay, yeah, so if you look, yeah, D and E are on the table. A and B start moving straight. Okay, when I did it, for some reason, my D was immediately stopped. Let me try that one more time. Okay. Let's double check that. Okay, another way to, when you're debugging, is to kind of simplify. All right, I just want to see if I can, if this thing is actually working. I want it to move straight. Oh, I see the problem. Okay, okay. Yeah, something, perhaps my axle isn't in all the way, or it's got some sort of a, yeah. No, I think the code's right. For some reason, my robot isn't driving quite straight. Try 50. Okay, but yeah, I believe the logic is correct here. Yeah, so we want it to move until the left side sees see the edge, and then we want it to align the right side afterwards. Okay, so give that a try, and then we'll move on to the next part. Okay, the next part is simply a generalization of the last part, because in some situations you can't guarantee which side of the robot will see the edge first. So what you want to do is look for either side to detect the edge. Right, and we went through this a little bit earlier, but then at that point you want to align to the edge. So you need to know which side detected it, and then depending on which side detected it, you do different things, right? One thing or the other. So that's the simple logic. All right, so let's do that. Okay, so we need an OR operator. So instead of just looking for the D side, we want D side or the E side. So we duplicate, change it to E. All right, so at that point, if either side detects it, then we can go on to the next step, which is determining which side detected it. So we say, once we've detected either side, was it the D side? If it's the D side, we know the answer. We just do what we were doing anyway, or in the previous exercise. If not, we do something similar, but with the opposite. Okay, if the answer to this is no, then that must mean the E side had detected it, right? That's going to be our assumption. So we want to stop the B motor, and we want to allow the A motor to continue until the E motor side, I'm sorry, the A motor side, which is the left side, detects it, and then we stop. All right, so give that a try. It should look very similar, except for it's just, it'll work. Okay, I just gave mine a try, and I think I found something slightly different. Okay, yes. if we use the other side, this needs to run -25. I think that's the one. Let me think. No, take that back. What? DE. Okay. Yeah. Let me try it one more time. What happened there? Okay, so the B side. Yeah, my robot went backwards for some reason. I think that's correct. I think that actually needs to be a -25. So let me try that. Yeah. Yep. Okay. That was the problem. Yeah. So if the D side sees it, then the A motor actually has to move at -25 to go in the forward direction. Yeah, it's a little different from the EV3. All right, so give it a try. Hopefully you'll get the similar results, which is basically both color sensors aligned with the edge once this code is done. I have a, yeah, I'm not sure if I have a, yeah, it's actually probably this one. Again, so it goes until either side sees the edge, and then it moves the opposite side to align. Yeah, so it's very useful technique for the Robofest game. All right, so hopefully you've been able to get that to work. And we're going to move on to the next section. Okay, so yeah, this one is special for this year because this year's challenge involves doing a lot of grabbing and lifting of objects. So we're going to cover that. Yeah, so hopefully you have a workshop robot that's similar to the, or a robot similar to the workshop robot, which has a claw and an arm that can pick up rolls. A couple basic ways I'm going to cover for controlling the arm and the claw. The easiest way, and I suggest you start with this, is time, right? Because that's the most reliable as far as just getting the program to run. Then once you got that figured out, you can try using rotation, the built-in rotation sensors to control them. Yeah, so as an example, we're going to start with the arm, making that go up and down. Right, you want to establish a 0 position, similar to how we use the base to follow a distance, and then make it move from that relative position. But yeah, first with time, it's really simple. You just need to know what direction your arm is running, and then to just tell it to go for a certain amount of time. You go in one direction to raise it, another direction to lower it. Yeah, so let's try that. I'll leave that there. You don't need this right now. This for controlling the arm. Okay. Okay, what did I say? I believe mine, okay, I think it's clockwise. We'll see. Okay, so if I run that. Yeah, okay. Yeah, so on this particular robot, yeah, clockwise will turn the arm forward. So you can, yeah, try different numbers. Let's try 2 seconds. Okay, then if you want it to run down, you can change the direction. Yeah, so give that a try. Yeah, just be careful with some of these high gear ratios. It's a lot of force, so you might want to stop the program if it looks like you're gonna possibly cause some damage. But yeah, so yeah, give it a test to just verify what direction your robot needs to be set for raising and lowering the arm. For mine, clockwise is up and counterclockwise is down. And I just use time to kind of get a feel for that. So, I mean, time's perfectly fine. You can use that, but if you want a little more precision, you want to use the encoders. And it's similar kind of thing to the, as I said, to the edge following. Using the encoders, you establish a 0 position, and then you raise it for a number of degrees. And then if you want to go back to 0, you just say go back to 0. All right, so we're going to do that. Okay, yeah, and again, I think that was more motors. I'm going to set my C motor. Oh, okay, that's the wrong one. Yeah. C motor is 0. Yeah, I kind of wish they would group the all the motor functions in the same place. Okay, I'm gonna set to 100. Yeah, so I like 100 going up because you need all the power you can get. Going down, you could probably reduce the power. Okay, what was that run? Let's see, it's under more motors. Yeah, there are a lot of there are more options here than the old EV3 language. So I think a lot of this is going to take a bit of experimentation since it's fairly new. Okay, yeah, so let's try something a little different. I'm going to try going to 1000. And then it's going to wait a second and then go back to 0. And I'll slow this down just for an example. Okay, let's try that. Whoops, oh, I just found a mistake. Okay, this is C. Okay. All right, so that worked for me. Hopefully that worked for you. Yeah, again, you can experiment, try to find your maximum height. Yeah, I'm gonna go up fairly slowly. We'll try 1500. Okay. Let's see. Yep, I forgot to reset my arm here. Yeah, since you're doing this kind of repeatedly, it's helpful if you can, have some confidence where the arm position is. So that's why I believe using rotation sensor position is better than just using time for controlling the arm. For the claw, it's a little different because you're kind of squeezing the claw, but still it'd be nice to try to be able to get the claw back to a known position at certain times during the game. Okay, so it's a similar kind of thing. You set a relative position, and I use time for squeezing the roll, but then I use rotation to try to go back to 0. All right, so hopefully you have a toilet paper roll and you give that a try. I'll set mine up here. Yeah, we're going to be getting into my blocks in a minute, so I'm actually going to take my claw stuff and save it in the my block, or arm rather. What's going to call it? Arm. Raise arm. All right, so yeah, this is how you create a function. You hit save, and then this is what it will do if you use this block. And I'm gonna just use this. Yeah, I know it. For my robot, these blocks will raise it almost all the way up. Okay, so controlling the claw. Okay, that's the F motor. Okay. Gonna set the speed to 0. I'm sorry, speed to 100, position to 0. And then we're going to use time to squeeze the roll. Yeah, so this is where I find time is better than using like rotation to squeeze it. And then we'll just hold it for a second. And then release it. But I'm going to use rotation to is this the one? Yeah, okay. Counterclockwise to 0. Okay, so give that a try. Okay. Yeah, so it should return to approximately the original starting position if that was set right. Yeah, one other. Okay, so hopefully you're able to control your claw. Then the last thing we want to do is kind of combine the movement, right? So we're just going to do kind of a static exercise right now without moving the base of the robot. We want to grab the roll, lift it, right? Let's prove it can lift it and then put it back down, right? I'll show you what that looks like. Whoops. Looks like this link isn't activated. Let's see. Give that a try. Okay. It should look something like this, right? Grab it, lift it, hold it, and then just put it back down and release it. Right? If you can do that, then you should be able to, after you lift it, you can move it a little bit and then set it down like if you were trying to stack, for example. You will notice, though, that the weight of the roll is a challenge for the robot to handle, but that there are ways of getting it to work. All right, so that's what we're trying to do here. Okay, so I'm going to switch over to the software. And it's basically just using the blocks we just went through in combination. All right, so at the beginning of the program, you want to reset your, or you want to make sure your arm motor is also set to 100. Then also make sure your arm motor is set to 0. And this assumes that your arm starts all the way down. Yeah, so it doesn't matter either. Okay, so we're gonna set everything to 0. Close the claw. Then we're gonna, raise the arm. Or if you might remember that these are the commands to raise the arm. Then, yeah, it's just gonna wait for a couple seconds. Then, assume it would bring it to where we want it to go, right? That's where you would insert the code to drive to a certain part of the field. But right now we're just gonna hold it up in the air, and then we want to bring it back to 0, or bring everything back down. So first we want to lower the arm. And then open the claw. I believe that's all we were doing, right? Maybe. Oops. Yeah. Okay, I think that should work. Give it a try. Yeah, I'll give mine a try. Close. Okay, oh, I've got a mistake here. Okay, hold on. Set to 0. Speed. Okay, here it goes. Let's see. C. Sorry, that we okay. Close claw, raise. Okay. Okay, well, so hopefully that worked for you. I will get some clarification on these relative positions to make sure that we understand how that works correctly. Okay, yeah, I believe we're okay. Yeah, 2 more sections, correct? Yeah, okay. All right. Yeah, my blocks. So those of you familiar with other languages, you know, it's very helpful if you can create custom blocks that can replace sections of your program, right? This way you can have validated code that you can reuse and not have to, do a lot of recreating or reduce the amount of recreating. So for example, if you have a section of code that where you're going to the edge a lot, you can substitute these blocks with a single block like a my block. I guess more impressive would be the align function that we created, right? That's a lot of blocks. You don't want to have to create every time, and you can replace that set of blocks with a single my block. Yeah, so let me demonstrate that. Yeah, so we can just even just use this last exercise, right? If we want to be able to do that set of blocks, you create, click on make a block. Roll, I will call it, and then hit save, and then it creates this other block where it wants you to define what happens. So you simply put in there, and then if you want to execute that code, you find, right, every time you want to execute that code, you just grab another block, my block, right? That's all there is to it. First, yeah. Well, then let me talk about some other things. If you want to modify the block, you can do that. If you want to use an input, right, you can do this. Right, so let's say I wanted to adjust the amount of time it waited. Instead of just saying 2 seconds every time, I can just say, well, tell me how long you want it to wait each time you use the block, right? So that can come in helpful. Yeah, let me see if I can think of it. Okay, yeah. Okay, I happened to save this set of code. I'm going to call this line distance. And which is basically going to be following the left side of the table for a distance. And we're going to use that a lot. And we probably want to go different distances each time we use it. So we can just do something like this. Oh, yeah. It turns out this isn't my distance code. That's okay. We can convert it very quickly, I think. Wait until. Yeah, this is good practice, I think. We were setting a position to 0. Yeah. So yeah, we don't know where we want to be able to use this many times, but at varying numbers of degrees, this is how you would do it. Oops. So with my blocks, you can create kind of a usable library. And then when you actually do solve the task, you can just build different combinations of blocks. So for example, right, you might want to go for 1,000 degrees, for example. Then you want to pick up the roll, hold in the air for 1 second, and then you want to go a little farther. So you want to go another 500 degrees, right? And then you want to set it down. Yeah, one thing to remember though, when you get, if you get into trouble, you need to trace your program, right? So pick up roll isn't doing what I initially really wanted it to do. So it closes the claw, raises it up. Okay. Yeah, so I don't want to bring it back to 0. I want to just pick it up, right? So I'm trying to simulate like stacking. So it would be something like that. Pick up the roll, and then over here I would add code to lower it back down. Right, so those could be very useful, right? You can use it for code that you're doing using repeatedly, or you can also use it to define a section of the program, right? So rather than having a whole bunch of different blocks in your main program, you can create like a subsection. You can say like mission 1, and then have all the different blocks that define mission 1. Yeah, so I've found it very helpful. And hopefully you have too, if you have experience with other software, but this is how you do it with the Spike Prime Scratch language. Right, so these are my blocks. And again, you can add inputs if you want. Okay, the last section, it's kind of a bonus section. Yeah, I think I'd mentioned that the Spike Prime does not, it only has 6 ports, so it's kind of limiting. But one thing it does have, it has a built-in gyro sensor, which can be very helpful. So what is a gyro sensor? It basically measures different movements of the brain, the hub. For our purposes, I'm going to keep it simple. We're just going to use the yaw, right, which is this direction, which you can use to make accurate turns. Okay, so I'm going to basically create a couple of functions that can accurately turn, right? The turns we've been, I showed you earlier, basically use the built-in rotation sensors, but I believe this gyro sensor is actually more accurate. So the way it works, you have to know which way is positive and negative. So a clockwise rotation is positive with the spike prime, and the left-hand turn is negative. Right. So what that means is as your robot turns right, the angle increases. So what we do here is we set the angle to 0. We get it turning right. And then once you reach your angle, you want to stop. And then going left, it's just the opposite, except for you're going, yeah, it's just the opposite. You set the angle to 0, you get it turning left, but then at that point, your robot is, the angle is getting more negative. So an easy way to take care of that is you basically just take the absolute value and just say, well, when the absolute value is greater than the angle you want to stop moving. All right, so let's do a quick demonstration about that. Yeah, I'm gonna throw these away. Okay, yeah. It's probably a good idea just to set your one of these. Let's make sure we're using A and B. We've got to find the gyro. Where is that? Yeah, set the angle to 0. Set the speed to 25. Get it moving left. Wait until you reach an angle. And this is the yaw for the, yeah, let's use 90, but that's an easy one to check. And then you want to stop your robot. All right, I think that's all you need. Yeah, give it a try. Oh, sorry, that's supposed to be a right angle. Yeah, okay. Yeah, so that's a right turn, 9 degrees. You can try different numbers just to see. And then in the presentation, I just genericized it to, you can input whatever angle you want every time you use the my block. Let's try 180. Yeah, it's a nice sensor. It gives very accurate turns, I've found. Okay, 180 seems to be a limit. Let me try 160 or 170. Okay, yeah, okay. It looks like this might reset at 180, so you got to be careful. Yeah, it looks like you don't want to go over 179. Yeah, so that's why it's important to kind of test your code. Yeah, it looks like there's a limit somewhere above 170 where the sensor will do some sort of a reset. So be careful about that. Okay, so let's, yeah. I think in most cases you generally want to do something like a less than a 180-degree turn. So hopefully that'll work for you. But yeah, it's important to know the limitations. And then let's just quickly do the left turn. Yeah, so if you want, you can save that in my blocks. But for a left turn, because I said it's similar, except you need the absolute value. So where is that? Absolute value of the y angle. That's it. Okay, and then you can try different variations of that. Yeah, so hopefully that's working for you. Yeah, I've found it gives some pretty accurate turns. It's a nice feature, and it doesn't require any additional wiring. It's built right into the Spike Prime brain. All right, so that's basically what we had for you today. Just to review, we talked about finding the edge of the table, following the edge. Once you can follow the edge, different ways of stopping it once you reach the corner or the target zone, or you could do it once you've gone a given distance. Yeah, oh, I'm sorry. Yeah, okay. Actually, we didn't talk about finding a paper roll because of the lack of ports. So you could try to do that, but if you use the ultrasonic sensor and it can detect the roll, you're gonna have to give up something else. Yeah, so that's. But we did, yeah. So that I'm sorry, that's a mistake that we didn't cover that this morning. But we did cover training the robot using spin turns or swing turns, aligning to an edge, manipulating the paper rolls, building my blocks, and then lastly we covered gyro turns. So we've got a post-assessment link. I'd like you to go through that afterwards. But at this point, are there any questions?
This is Jason.
Yeah.
Thanks for sharing. Yeah, I found that the spike component is not enough to make claws or lift components. So
Yeah, no, you're going to need extra parts. Yes.
Yeah, like the large gears.
Right.
Like that.
60-tooth gears. Yeah.
So if the students just buy the bike and expression sets, they cannot compete either.
No, yeah, they would need more parts. Do you want me to send you or you have you know what else to have that they need, right?
Yeah, they still need to use the EV3 parts. And
yeah, okay, right, yeah, no, I'm not sure if that's a way of them keeping their price down, but yeah, yeah, I mean, for the Spike Prime kit, I needed to buy an additional color sensor, additional motor, and yeah, those extra parts you mentioned, the gears and some beams, I think.
Yeah, and so for the fighting roar parts that you mentioned for the limitation of the ports, that kind of worry
Yeah.
about it.
Yeah, okay, let me, I think there, with this game, there's a way around it. Yeah, let me give you my suggestion. Oops, wrong one. Yeah, one thing that's you do know is there's certain limits to where these rolls can be, right? So for yeah, let's use roll 5. What's that? Dimension E, 12 to 100, right? So it could be somewhere from 12 to 100.
Right.
Right. So if you program the robot to, follow this edge and then go push the roll forward all the way to here, you've covered the whole range, right? And you can be pretty sure that at that point your robot is here with the roll.
Right. So you can only determine by the distance.
Right. It's blind, right? You're not sensing it, but still, based on the givens of the game, I think you can do it okay.
Right.
Yeah, so
Right.
same thing here, what D is between 12 and 62. So I would make sure I'm pushing from, the 62 all the way down to 12 and then go from there. And then same thing with, what's C? Yeah, C is probably if you're doing senior, that's the one where you might need multiple programs to be able to encompass the different conditions. But yeah,
Right.
it sounds like you understand what I'm suggesting, right? It's
Yeah.
not ideal, but it does. You can still do it, right? If all you have is the spike prime.
Yeah. Just for the new students who enter into this area, if they only have spike prime, it's not enough for them, and so we still need to look into maybe like EV3 or even Vex IQ for other more reliable.
Oh, I don't know. I think we can. I think you can try to make do with that.
Mhm.
Yeah, I don't know. I mean, that's. I think you find that with other things, there are almost never enough sensors, right? Or,
Mhm.
or yeah, you always could use another motor. It seems. Yeah, I don't know. I guess
Yeah, and this year the Lego is raising the price high for the spike to the standard of like EV3, and they're
is that
facing.
right? Oh, that's too bad. I mean, yeah, if you think one of the other kits is better, yeah, I guess it's probably worth a try. It seems like no matter what, within 7 years or so, it's going to be obsolete, right? I guess my concern with the other two, though, they've been on the market for a while, so they're likely to be replaced soon.
Right.
Yeah, I don't know that for sure. I mean, yeah, for sure, the EV3 is going to be phased out, right? We know that for sure. I mean, my guess is the Vex IQ is due for an update as well. So that would be my only concern with using those kits. But I agree with you. I think that's quite a it's a bit of a disadvantage with the 6 ports. Yeah, I don't know. Have you seen any sort of multiplexer?
No, not
No, I
yet.
wonder. I mean, that could solve the problem, right? If there's a
Yeah.
way to get another port, some sort of port expander. But yeah, I guess I don't even know for sure. I actually have you. I didn't do much testing with object detection using the spike, so I'm not even sure if the ultrasonic sensor would work. on the toilet paper roll because, you know, they're kind of absorbent. I mean,
Right.
perhaps another color sensor.
Right.
Yeah.
Yeah. So yeah, I'll try it and let you know too.
Yeah. Okay. Okay. Yeah. Like I said, it's a in a way, it's interesting. It's new technology, but yeah. There's some unanswered questions, and yeah, I will get back to you on the rotation. Yeah,
Me too.
how to use rotation blocks.
Yeah. Thank you. Thank you for
Okay.
sharing.
Thank you, Elmo. You know, you are doing, I think, the first spike.
Yeah, I'm sure there have been some other ones, but yeah, I haven't seen any.
So can you briefly explain about the difference between now and the one, you know, at 1? You are having another one today at 1.
Yeah. Well, 1 second. I just need the message, Shannon.
And Jason, you sent an email about the change of the web page. That's what you were asking?
The web page.
Did you send an email this morning? I mean, just before some hours ago?
Yeah.
Yeah, Shannon, I think you can stop the recording now.
Okay.
Yeah. The web page can be